This section actually starts with discussion about significant figures. We're not going to deal with any of that in this class. I want you to continue to round to 3 decimal places. We are going to start, however, with solving triangles removed from the coordinate plane, and we'll start with the 2 vocabulary terms, angle of elevation, angles of depression. An angle of elevation starts with the horizontal line, and you always measure up. It can start with a horizontal going in this direction. As long as you are measuring up from the horizontal, it is an angle of elevation. Similarly, an angle of depression will start with the horizontal, but it will be measured downward. And again, regardless of the direction of the initial side, angle of elevation is always measured in the downward direction. So let's jump in and get started. We're asked to solve right triangle ABC when we are given angle B and side A. The first thing that you absolutely must do is draw the triangle. This is our right triangle. Here is angle C, angle A, angle B. So this is 28 degrees, 40 minutes. Here's side A, which they gave us, and that is 25.3. Here's side B, side C. So the first thing that I need to do is calculate angle A. I will use what's called the triangle sum theorem, which means if I add all 3 angles of a triangle, it must equal 180 degrees. So 180 minus 90 minus 28 degrees, 40 minutes is going to give us angle A. So angle A is equal to 61 degrees, 20 minutes. This is a calculated value, so as we proceed, I would not recommend using a calculated value if you can avoid it. Sometimes it's unavoidable. To solve the rest of the triangle, we'll use the acronym SOHCAHTOA. If I want to solve for side B, I know that angle B is opposite, and the other piece that I have is adjacent to angle B. So if I'm looking at opposite over adjacent, I need the tangent. So that tells me that the tangent of 28 degrees, 40 minutes is equal to B over 25.3. Algebraically, I multiply by 25.3 on both sides. It clears my denominator. And then into my calculator, I just put 25.3, tangent of 28 degrees, 40 minutes. That gives me a length of side B as 13.832. Again, I would not use this calculated value to find side C. I would continue to use angle B and side A. So I know that side A is adjacent to angle B and side C is the hypotenuse. So if I'm looking at adjacent and hypotenuse, I need cosine. So that's the cosine of 28 degrees, 40 minutes is equal to 25.3 over C. Again, when we look algebraically, we would multiply by C on both sides. That would allow us to clear this denominator, and you end up with C times the cosine of 28 degrees, 40 minutes is equal to 25.3. Now, because I'm multiplying C times the cosine, I have to divide by the cosine on both sides so that I can isolate C. And now I've got that C is equal to 25.3 over the cosine of 28 degrees 40 minutes. If you look back at our original, you can see that the c and the cosine end up switching places. I've shown you the algebra, but the shortcut is that if you have a variable in the denominator, you can move it to the other side of the equal sign, and then move what's isolated to the denominator. And then, of course, this can simply go right into your calculator. And I get that side C is equal to 28.834. So if I'm writing out a solution, I might say angle A equals 61 degrees 20 minutes. Side B is equal to 13.832 centimeters. And side C is equal to 28.834 centimeters. For the next right triangle, I'm given two side lengths and no angles. So I will again sketch this triangle. Side A is 44.25 and side B is 55.87. This will be one of those instances where you will be required to use a calculated value in order to find something else. I do not want you to use Pythagorean theorem to find side C. We are doing trig, and I need to assess your ability to do trig. So let's start off by finding angle A. If I look at what I've got, here's angle A. I've got opposite and adjacent, which means that I will be looking at the tangent of angle A. In this case, I've got a ratio and no angle. To find the angle, I need to use the inverse function. So I take the inverse tangent of my ratio, and that will give me the angle. I get that angle A is equal to 38.380. To find angle B, it's okay with me if you use the angle sum theorem. So 180 minus 90 minus 38.380. That gives me that angle B is equal to 51.62 degrees. After this, we just have to find the hypotenuse. You can use either angle A or angle B, it doesn't matter. But when you do that, I'll just use angle A. I can use opposite over hypotenuse, or I can use adjacent. Again, it doesn't matter. I tend to prefer sine, so I will do the sine of angle A is equal to 44.25 over C. Now this is one of those cases. I've got a variable in the denominator, so I can just have these two switch places. C is equal to 44.25 over the sine of 38.380. For this, I get that side C is equal to 71.270 centimeters. So again, if I were to write it all out, angle A is 38.380 degrees. Angle B is 51.62 degrees. Side C is 71.270 centimeters. So the last problem that we'll look at is a word problem, and it actually involves that angle of elevation that we talked about. So the length of a shadow of a flagpole, 55.2 feet tall, is 27.65 feet. Find the angle of elevation of the sun. So here are the things that we have going on. First of all, we have a flagpole. And the flagpole is 55.2. Then we have a shadow that's on the ground. So the shadow is just flat, and it's 27.65. We have to find the angle of elevation of the sun. Remember, angle of elevation comes up from a horizontal. So there's your horizontal, and the angle of elevation needs to come up. So this is your hypotenuse, and we're looking for this angle. We will always assume that flagpoles are perpendicular to the ground. So I've got angle A, I've got the side opposite, and the side adjacent. So that means I need to use the tangent function. So the tangent of angle A is 55.2 over 27.65. Here I have a ratio but no angle, so I have to untrig this or take the inverse of the ratio. And I get that angle A is equal to 63.393 degrees. Of course, this is a word problem, so I will write my answer in a complete sentence.